We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Getting my feet out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 33 minutes past the hour. Liftoff on Apollo 11.
Listen, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 129 of the Space Rocket History Podcast. And now, Apollo Mission Control, an introduction to Eugene Francis Kranz. Eugene Francis Kranz was born August 17, 1933, in Toledo, Ohio, and attended Central Catholic High School. He grew up on a farm that overlooked the Willys Overland Jeep production plant. His father, Leo Peter Kranz, was the son of a German immigrant and served as an army medic during World War I. His father died in 1940 when Gene was only 7 years old. Kranz has two older sisters, Louise and Helen. From a very young age, Kranz developed a unique interest in spaceflight. He formally declared his interest in the subject by writing a high school thesis which explored the possibilities of flying a single-stage rocket to the moon. However, after graduating from Parks College of St. Louis, Missouri, with a B.S. in aeronautical engineering in 1954, Kranz's interest became more down-to-earth as he shifted from space travel to aviation. He received his commission as a second lieutenant in the U.S. Air Force Reserve, completing pilot training at Lackland Air Force Base in Texas in 1955. Shortly after receiving his wings, Kranz married Marta Cadena, a daughter of Mexican immigrants who fled from Mexico during the Mexican Revolution. They eventually had 6 children: Carmen, Lucy, Joan, Mark, Bridget, and Gene, spelled with a J. The Air Force sent Kranz to South Korea to fly the F-86 Sabre aircraft for patrol operations around the Korean DMZ. After finishing his tour in Korea, Kranz left the Air Force and went to work for McDonnell Aircraft Corporation, where he assisted with research and testing on the new surface-to-air missiles and air-to-ground missiles for the U.S. Air Force at its research center at Holloman Air Force Base. In 1960, Kranz answered a help-wanted ad from NASA in Aviation Week. Kranz soon found himself employed with the newly formed Space Task Group at NASA's Langley Research Center in Hampton, Virginia. Upon joining NASA, he was assigned by Flight Director Christopher Kraft as a Mission Control Procedures Officer for the unmanned Mercury Redstone 1 test flight, dubbed the 4-inch flight due to its failure to launch. Now I thought it might be interesting to hear Gene Kranz describe his early life in his own words. This was recorded in the Mission Control Center at Houston.
I was fortunate that when I was going through high school, in fact, well before high school, at the time I grew up in Toledo, Ohio, and my father died when I was 7. So my mother had 2 kids plus myself, 3 of us to raise. This was during the Depression with no insurance, no money around the house, etc. She opened up a boarding house And in the process of doing this, we had all the soldiers, sailor, and airmen that lived basically at our place as I was growing up. And we generally have about 3 to 4 military personnel, and then we'd get all the rest of us squeezed into one room, sometimes 2 if we were lucky. But it was there as a result of my association with these warriors that I developed absolutely a passion for aviation, a passion for flying. And that became my driving force. As early as I could move out on the roads, I used to hitchhike over to Cleveland for the air races, and then I had an accident over there and went up to Detroit for the air races. So that aviation was my passion, and that was the key that drove me to a small college in East St. Louis, Illinois. It was part of St. Louis University called Parks Air College. And Parks Air College was a truly unique entity at that time. There were about 5 aviation colleges that specialized in aviation within the United States. And they were very, very competitive. You had Spartan Aviation was one, Parks was another, 2 or 3 others, and they had a Hilliard that was down there. But basically, in the process of doing this, the whole objective was to teach people to fly. So they actually provided the pilots for the airlines. And to a great extent, military services. Park graduated a large number of people during World War II that would fly the fighters and bombers over there. And basically, I went to Parks, carried class loads were very high there. We generally averaged about between 23 and 26 semester hours per semester. And we worked in a trimester system. So basically, that allowed us to get out in 3 years. In the process of doing that, however, the requirements for graduation was you get your degree, or aeronautical engineering degree. I got my aircraft and power plants license, so I became a licensed maintainer of aircraft, and I got my first 10 hours flying time. So it was the background I had when I left college. I went into the Air Force and was very fortunate to go through a pilot training down at Spence Air Base, where I met several incredible individuals who pretty much provided the steering I needed. A young guy getting in, just in the military, going through flying training. A guy by the name of Jack Coleman. And Jack Coleman was basically the individual who taught you to fly that you never forget. But in particular, in the process of learning to fly, he taught you basically to move right to the boundary of the performance of the aircraft and your own performance and look over the edge and basically accept that as a great way to live. And that provided the background I needed when I went into jet training. And then finally, in those days, Top Gun school, they didn't have such a thing then, but it was really the fighter weapons school at the Nellis Air Force Base. I went through and started flying the first of the major subsonic fighters. I flew the F-80 out there, flew the F-86. And so I had the opportunity to fly the early subsonic fighter aircraft. And then I moved into the F-100 Super Sabre, which is the first aircraft that could exceed the speed of sound in level flight. I had a bunch of 86 time at this time, so basically they retreaded me, sent me over to Korea with the 86 squadron over there. Came back stateside, and I was looking for my next direction. I felt I wanted to move into aircraft flight test. I wanted to continue this process of growing. And I was fortunate to get a slot in flight testing of the early jet bombers, the B-47 and B-52. And spent several hundred hours in the business, and it was an interesting test program. The B-52, it was relatively new in the production line. We were going through adapting various weapon systems through it. We dropped various shapes out of the bomb bay, see how they free fall. We put ducts, tufts all through the bomb bay and to map airflows in there and take high-speed photography. We did a lot of work in the air-launched missiles in that area, and we also did a lot of work in the decoys. But as I was as we were wrapping up that program, I saw an advertisement in Aviation Week that indicated that they were forming a space task group, and I thought, gee, that's pretty cool. I sort of like the idea, and the words, the exact words, space task group to determine the feasibility of putting an American in space. And I thought, gee, they don't even know they can put him in there yet. They were looking to see if it's feasible. And basically sent in the standard government form 52. About 6 weeks later, I got a call. They said, "Are you interested in joining up?" I said, "Yep." And about 3 weeks later, I was at Langley Research Center. And basically I went into a pool of other engineers that were there because they still hadn't figured out how this organization was going to work. Some people were going to go to engineering, some down at the Cape for launch operations, some into trajectory design, some in flight operations, some in launch operations, and pretty soon a guy comes along after about 2 weeks in there, taps me on the shoulder and says, "I'm Chris Kraft, you're working for me now." And then he said something very interesting. He says, "I want you to go to the Cape, write a countdown, write some mission rules, and when you're through, give me a call and we'll come down and launch." 2 weeks in the job. And that is basically how this thing works. So in the process, I had the opportunity to really learn the business of space, basically from the ground up, but also learn it from what I would say was the master of spaceflight operations at that time, or the man who would be the master of spaceflight operations, Christopher Columbus Kraft. So then let's fast forward a bit, and I'll give you a bit more of the history, but I'll do it in a slightly different format. You know, when Jim Lovell called down from the spacecraft, "Hey, Houston, we got a problem," all I had was my team in mission control, this exact room, and a learning curve that started about 10 years earlier at a place called Cape Canaveral. At that time, the Cape was nothing but sand, marsh, salt grass, corrugated steel buildings, and antennas. When I was there, we learned of leadership, trust, values, and it was there that we became a team. Mission Control, this room is a marvelous leadership laboratory where we teach our young controllers to achieve excellence as an individual, as a team member, and as a leader. And here we learn the difference between the I and the we part of the team, because when their time comes, we need our controllers to step forward, assume a leadership role, make their contribution, and then when they're through, return to the ranks within the team. Our work develops chemistry, because chemistry in any organization is a force amplifier. It amplifies the individual's talent as well as the team's talent. And chemistry leads to communication in this room that is virtually intuitive, because we must know when the person next to us needs help, or a few more seconds to come up with an answer. And in mission control, there's no such thing as a first team, because once we launch, every team must be capable of accomplishing the mission. And finally, when we must act alone. And in this room, we know that time will come to each of us. We are never alone, because we know our team stands with us. In our line of work, failure is not an option.
The banging you might have heard in the background is actually Kranz gesturing and hitting one of the control panels. As procedures officer, Kranz was put in charge of integrating Mercury Control with the launch control team at Cape Canaveral, Florida, writing the go, no-go procedures that allowed missions to continue as planned or be aborted, along with serving as a sort of switchboard operator using a teletype machine to communicate between the control center at Cape Canaveral and the agency's 14 tracking stations and 2 tracking ships located across the globe. Kranz performed his role for all unmanned and manned Mercury flights, including the trailblazing Mercury Redstone 3 and Mercury Atlas 6 flights, which put the first Americans into space and orbit respectively. After Mercury Atlas 6, he was promoted to Assistant Flight Director for the Mercury Atlas 7 flight of astronaut Scott Carpenter in May 1962. He continued in this role for the remaining 2 Mercury flights. Here's a clip of Kranz recounting his experience with Mercury.
When we started in 1960, our world was vastly different. Our nation would soon be torn by the beginning of the conflict in Vietnam. During that decade, we would see 3 political assassinations, and the civil rights movement was just emerging within the nation. The Cold War with the Soviet Union provided the stimulus for the space program. It guided every aspect of America's foreign policy. Computers existed only in laboratories. There were no global communications, and in that decade, American students would riot on the campuses. And then in 1961, a young, brash, and articulate President John F. Kennedy issued a challenge. He said, we choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they're easy, but because they're hard. And when he issued this challenge, we were struggling to put a spacecraft in orbit. 1 month prior to that speech, we had blown up our second Atlas rocket. 9 days prior to the speech, we had launched Alan Shepard. We had a total of 20 minutes manned spaceflight experience. We'd never been to orbit, and we were challenged to go to the moon. So engineers and people experienced in flight tests, and a small group of 31 Canadians and Englishmen from the Crackerjack Avro Aero flight test team joined with the Mercury 7 astronauts at Langley Field in Virginia to form a space task group that would win supremacy in space. Our boss was Walt Williams. Walt was the toughest man I have ever known. He is a brawler. He is more fitted to working as a longshoreman in New York or New Orleans or San Diego than leading the American space program. But in the business of aircraft flight tests, Williams was a legend. He was the pioneer director of the NACA high-speed test station that today we call Edwards Air Force Base. And he's a project manager for the X-1 rocket ship that in 1947 took Chuck Yeager and the world into the age of supersonic flight. Williams' deputy was prophetically named Christopher Columbus Kraft. Chris was the pioneer. This control center is rightly named for him. He developed the concept of spaceflight operation, directed the implementation of the worldwide tracking network, launched each one of the Mercury missions. But the most important thing was he was the mentor, the teacher, the tutor for the first generation of young people that became known as mission controllers. Mercury Control did not have a single computer. There were 3 mainframe computers supporting all of Project Mercury. 2 of these mainframes were located 700 miles north of the Cape at Goddard Space Flight Center in Greenbelt, Maryland, and they were the first fully transistorized computers. They were located up there because IBM did not trust us to operate these machines. On the island of Bermuda, we put a reliable vacuum tube computer with a small team of 7 controllers. We always launched eastward over the island of Bermuda, such that if we lost communications with our crew during powered flight, the team in place would tell the astronauts what to do when the engine shut down. Global communications consisted of a 60-word per minute teletype network that dated back to the days of America's Pony Express. So after a couple weeks training in spacecraft systems and operations, and after we all became very proficient in Morse code, because Morse code was our backup form of communication within the ground tracking network and the crew on board the spacecraft. So after we achieved this proficiency, that was a number one capability we had to teach our young kids. We sent young men to 13 tracking stations around the world. They went into the heart of Africa. They went to Zanzibar. They went to Australia, ships at sea, islands of the Pacific. And the risk to these young people was very high. They were all your age. The risk was high because the 60s was the end of the European colonial period, and most of these countries were in a state of civil war. My controllers in Africa, the Kano Nigeria tracking station, were twice rescued by the Nigerian army. At Zanzibar, we would work under the protection of the Gordon Highlanders and the Queen's Royal Rifles regiments up there. They would surround the tracking station during contact periods, bring the controllers back to the quarters at the end of the ship. Station gunners at the top of the stairs became so violent at that site that we shut it down after only 3 years. But these young folks at these sites were eyes, their ears, and voices as the spacecraft passed overhead. And for their age, they were given incredible responsibilities. Now, we first went into space in Project Mercury, and each one of our launches was a chapter in the history book of spaceflight. Our mistakes were violent, they were brutal, they were visible. 2 of our first 3 Atlas rockets exploded shortly after they left the launch pad. Then we launched our first Redstone rocket. We sent the firing command, the engine ignited, lifted launches off the launch pad, then it shut down. Through some miracle, the rocket landed back upright in the launch stand without exploding. The escape power fired, it went up to about 4,000 feet, came plummeting down to the viewing stand, and the senators and congressmen ran for cover. Our rocket engineers were speaking in German. We didn't understand what they were saying. We literally did not know what to do. But we were fortunate in those days because our nation understood there is no achievement without risk. And there certainly weren't any guarantees in this new business we call spaceflight. We put 6 Americans in space in our first 2 years, and there were close calls in every one of those missions, especially in John Glenn's and Scotty Carpenter's. But we got every one of our crewmen home. By the time that we had finished with Project Mercury, we had learned that man could live and could perform in space, but we learned much more. We learned that leaders and leadership. Leaders have integrity. They're teachers, they're team builders, they're great listeners, and when there's trouble, leaders are out front. And we also learned a lot about ourselves as individuals because many of us came in from aircraft like this, and our ego was much bigger than this room. And it was tough at times to get people to work together. But we knew that success would only come as a team, so we became one. And we learned to check our ego at the door every day when we came to work.
Kranz continued his role as assistant flight director for the first 3 Gemini flights. Then he was promoted to the flight director level and served his first shift, the so-called operations shift, for the Gemini 4 mission in 1965. This was the first U.S. EVA and a 4-day flight. Now Gene explains what it means to be a flight director.
Now in our line of work, the boss is the flight director, sits right up that console in the center of the room. And he has probably the simplest job description in all of America today because it's only 1 sentence long. It says, the flight director may take any actions necessary for crew safety and mission success. That's it. During the course of a mission, he is the ultimate authority. And the flight director is supported by a team of between 15 and 21 controllers, people specialize in trajectories, spacecraft systems. You have operations, you have planners, procedures writers. You have a medical doctor who looks after the ground team as well as the crew in space, and we have an astronaut who provides communication during the course of the mission. And mission controllers are young. They're generally in their early to the mid-20s, and flight directors are in their early to the mid-30s.
Gene worked as the flight director on the Gemini 9 mission, and then he started picking up the responsibilities for the Apollo program. Chris Graff, Gene, and John Hodge were to be the first flight directors to fly the first manned Apollo mission. The remaining flight directors, Glenn Lunny and Clifford Charlesworth, continued to finish the Gemini program. And as they continued these missions, Gene would occasionally go back to Gemini and fill in on the night shifts for them to give them a bit of a break so they didn't have 7, 8, or 10 days of 2-shift operations continuously. Now I have a clip of Gene reflecting on his time spent with Gemini.
So we moved into the Gemini program, and Gemini was designed to develop and test and prove the technologies that we needed in order to go to the moon. One of these technologies related to the tools and the techniques we used in designing our mission trajectories. For trajectory design in Project Mercury, we had a very large group of women. There were about 100 of them. They were all mathematicians, and we called these women computers. Computers were people to us in the early days, not machines. And these women would travel this from the headquarters at Langley Field in Virginia down to the Cape for each one of the launches, and they'd bring their calculators along. They'd get down to the Cape, they'd punch away at the numbers, they'd write the answers down, they would plot it in graph paper, and these women would do this endlessly day after day just to design a single Mercury trajectory. Well, this approach wasn't going to get us to the moon. It wouldn't even get 2 spacecrafts rendezvous in Gemini, so we finally did get computers, and each one of these machines was as big as a house. 5 of them filled the entire first floor in our new mission control center in Houston, and even put a small 4,000-word computer on board the Gemini spacecraft. But the problem was we had no computer experience. So we went to the colleges and universities throughout our nation and brought in the young people who were working with computers in laboratories. We went to the Army Missile Command at Fort Bliss in Texas because the Army had been working with computers in the ground-air missile program, and we basically hired the corporals and sergeants there as discharged. And we took these new recruits and merged them with the Mercury veterans, and they started working in the very edge of all knowledge, all technology, and all experience. Now, when they first started off in space, the Soviet Union had about a 2.5-year lead on us. But when Ed White stepped outside the spacecraft in the Gemini 4 mission, we had now narrowed that lead down to mere months. And then, on the next 2 missions, for the first time, we set American and spaceflight records. First for mission duration, and then we rendezvous 2 spacecrafts. And when we had accomplished this rendezvous, we had developed the technologies needed to reach further into space. We had the confidence to use these new technologies. But we continued to learn of ourselves and of our work. We learned of discipline, of focus so intense upon the objective that we would never do anything personally in this room that would compromise achieving that objective. We also found the value of high morale because we now knew we were succeeding because of our beliefs in our mission, our team, and in ourselves.
After Gemini, Kranz served as a flight director on odd-numbered Apollo missions, including Apollos 7 and 9, and he was the flight director for Apollo 11 during the moment the lunar module landed on the moon, and he was the flight director on Apollo 13. Now, I have a lot of Kranz material on Apollos 1, 11, and 13 that I will use when those missions are covered. I do want to briefly touch on Apollo 13 with the understanding that there will be a whole lot more material from Kranz when that mission is reached. Kranz was probably best known for his role as lead flight director during the Apollo 13 manned moon landing attempt. Kranz's team was on duty when part of the Apollo 13 service module exploded, and Kranz's team dealt with the initial hours of the unfolding accident. His group of mission controllers were called the White Team, also known as the Tiger Team. The White Team set the constraints for the consumption of spacecraft consumables, such as oxygen, electricity, and water, and controlled the 3-course burns required to return to the Earth from the Moon, as well as the power-up procedures that allowed the astronauts to land safely back on Earth in the command module. Kranz and his team, as well as the astronauts, received the Presidential Medal of Freedom for their roles. Now here's a word from Gene Kranz on his Apollo flight directors.
A few words about my flight directors. I always operated with 4 flight directors. We did this to balance the training load at the beginning as the mission was starting up because it's very irregular and literally the training in here is as grueling and maybe even more grueling than missions in most times. So it's very intense, very extended. Also, our shifts are very irregular, some very short, some very short, so this gives the idea of moving a team in and out and giving a break at the midpoint of the mission. Most important reason, however, is one team is always designated as a crisis management team. And that happened to be my responsibility for 13. As soon as a problem occurred, it was up to me to get my team out of the shift rotation sequence, address the problem, come up with the solutions, and return to the console only when we had the answers. Glenn Lunny, the black team leader, was the youngest at 32. He came to us as a co-op from University of Detroit, was the first person I ever knew who worked with a computer. So he was the go-to guy to get the answers. I was the oldest of the flight directors, 37. My team color was white. Milt Miller was maroon, Jerry Griffin gold. The remaining 3 of us were all fighter pilots. We flew the late subsonic and early supersonic aircraft in the 50s, and I believe it was learning to live with the risk of early jet aviation that really allowed us to keep our poise with the very young people we had in the room. Our nation abandoned the moon. Gene Cernan was the last human ever to walk on its surface. And for us, it was a marvelous time to live because we believed in this dream they were given by John F. Kennedy, and we considered ourselves privileged and proud to be part of the brotherhood that formed in the early years of spaceflight. And we thanked our country every day they gave us a chance to participate in this great adventure. So this is the story of mission control, story of Apollo 13, but it's more a story of a group of young people just like yourselves maybe a couple of years, and a team that truly believes that in our line of work, failure is not an option. Thank you very much.
Kranz continued as a flight director through Apollo 17, when he worked his last shift as a flight director overseeing the mission liftoff, and then was promoted to Deputy Director of NASA Mission Operations in 1974, becoming Director in 1983. He retired from NASA in 1994 after the successful STS-61 flight that repaired the optically flawed Hubble Space Telescope in 1993. In addition to having written Failure is Not an Option, which was adapted for cable TV for the History Channel in 2004, Gene also flies an aerobatic aircraft and serves as a flight engineer for a restored B-17 Flying Fortress. Now I want to list just a few of the many awards Kranz received. Sperry Award, NASA Exceptional Service Medal, Presidential Medal of Freedom, NASA Distinguished Service Medal, NASA Outstanding Leadership Medal, NASA SES Meritorious Executive, Robert R. Gilruth Award, Lifetime Achievement in Aviation Award, NASA Ambassador of Exploration, Rotary National Award for Space Achievements, selected to National Aviation Hall of Fame in 2015, and Honorary Doctorate of Science from 3 universities, just to name a few. In conclusion, NASA's flight directors were pivotal to the success of the Apollo program. Throughout his distinguished NASA career, Kranz took on progressively larger and more capable roles, beginning with Control Procedures Officer and ending with Director of Missions Operation. Kranz's career was marked with some of the most noteworthy Apollo missions: the first moon landing on Apollo 11, the Apollo 13 near disaster, and the last landing on the moon with Apollo 17. Spaceflight is dangerous and an exacting business. Irreversible decisions must often be made with incomplete information under strict time pressure. Often the success of a mission or the safety of the crew can depend on these single moments. Kranz was confident in his ability to swiftly and correctly come to understand the salient aspects of these kinds of critical problems. Like any great leader, he was able to synthesize the provided information into a course of action that would ultimately become a solution, and he was able to stay cool and collected as he did so. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.